Hi everyone. Today I want to share with you something really exciting, a new breakthrough in cooling water treatment technology. Maybe this is the first time you hear its name. It's called CCD. Why did it create such a buzz in the water treatment world the moment it came out? Well, this isn't your typical chemical dosing system. CCD takes a totally different approach. It was created specifically to tackle scaling problem. But before I dive into how it works, let's take a moment to think about this. What kind of problems do factory cooling systems face every day? Let's take a closer look. Have you ever run into issues with your cooling system? Maybe during routine maintenance, you opened the chiller's condenser cover and saw a thick layer of white scale built up inside. Or after spending hours on chemical cleaning, you noticed the copper tubes in the heat exchanger had turned green and started corroding. Or perhaps every time you check the cooling tower, the water basin is covered in dark green algae. And yet, you've already been dosing chemicals, but the results just aren't what you expected. If any of that sounds familiar, it means you already have some awareness of how important water quality is in a cooling system. But let me show you why proper water treatment matters even more than you might think and how it can make a real difference for your plant. You've probably heard people say, good water quality management can help your factory save electricity. But is it really about saving energy? Well, to be more accurate, it's actually about keeping your equipment running at its original power efficiency. Let's take a 100-ton chiller that runs at 75 kilowatt for a whole year as an example. From this chart, you can see that as the system operates and the cooling water gets more concentrated, scale gradually builds up inside the equipment. As that scale layer gets thicker, say around 0.6 millimeter, the power consumption climbs to 90 kilowatt. At that point, the chiller is under heavy load, triggering alarms. In some cases, it might even shut down unexpectedly. That's when the engineering or maintenance team rushes in to do an acid cleaning on the condenser. After cleaning, power consumption drops back to 75 kilowatt. Problem solved for now. But if the factory still isn't maintaining the cooling water properly, the same issue will keep coming back. And the more often you do acid cleaning, the more you risk damaging the equipment through corrosion. Eventually, you might end up with a leaking heat exchanger that needs to be replaced entirely, and that's not cheap. This kind of situation happens all the time in factories. But if scale buildup in the cooling water is properly controlled, production becomes more stable, your maintenance team gets fewer headaches, and most importantly, your boss saves a ton on electricity bills. Back to our 100-ton chiller example. Let's say it runs 12 hours a day, 365 days a year. With electricity at about 2,200 VND per kilowatt hour, keeping that machine clean and scale-free can save the company around 72 million VND per year on just one unit. So think about it. How many water-cooled machines in your factory have been secretly losing money year after year, covered in invisible layers of scale, the real energy vampires?